All right, team. So today's exercise, which follows on from last session was total surface area. You had a formula for the cylinder. Today is going to be about volume of prisms and cylinders, most of which is quite similar to the Year 8 and Year 7 version. I thought I'd just recap the conversion bit and then just talk about where the formula comes from for the area. And then I was going to share one of the facts that I knew from this and how that helped me do a bit of the mathematics for my wife when we came to making what we call a bleach bath. That's what I was researching up before to show you, because it's a common recommendation. I'll explain it later. And there is a short way of doing it, or what I think is a shorter way, versus a longer way of doing it. But here we go. Volume of prisms and cylinders notes. Volume, like I said, when you're converting, because it's three-dimensional, notice that the conversion of the units now are cubed for each one. Now, have you forgotten the explanation for it? Again, because we're working in 3D, when we say 1 meter by 1 meter and then by 1 meter across, we get a 3D shape. And when we convert it, why is it that when we convert to cubes that we have to cube the value? It's because we're working in 3 different dimensions. Each dimension, say if I wanted to convert from cubic meters to cubic centimeters, well, then the logic is I need to convert this 1 meter into centimeters. And we know that in 1 meter, how many centimeters are there again? 100. So what you would have done here is you said times by 100. And then to get from this 1 meter, which is the height, you'd also have to times that by 100 to convert it to centimeters. And then you'd also have to times this by 100 to convert it to centimeters, which in turn, this volume is 1 by 1 by 1, which is 1 cubic meter, is equivalent to 100 times 100 times 100, which is why it's times 100 cubed. That's where it's coming from. So timesing 100 3 times is why we cube the transformation. Okay, all the conversion units. So that's the reason why we do that. Otherwise, if you know how to convert length units, then you know how to do area units, and hence you know how to do volume units. The other type is you got volume versus capacity. Anyone know the difference between volume and capacity? Almost used interchangeably. So we understand that length unit is how long one dimension is. Area is the space that 2-dimension covers. Volume, which now we're talking about 3-dimension, how much it can contain. What's the difference between volume and capacity?
Is capacity like how much of something, like how much of like a liquid fits into there?
That's beautiful. That's it. The only difference in the language we use is amount of liquid. We normally talk about capacity. So when we're talking about the milk that a bottle of milk, a 2-liter milk can hold, the 2 liters is the amount of capacity. Volume usually determines how much space or how much something can contain. So for example, a few years ago when I first moved to Viewbank, 2022, in 2022, when I moved there, I wanted to do a bit of renovations in the back where I just did a bit of landscaping. So I wanted to buy bark because there was a playground there, but it was all muddy. And if you walk on it, it gets really slippery. So I thought, yeah, let's get some bark, but how much bark do I need? And I measured the playground area, and I realized that it's convenient that it was just a nice 2D shape with a bit of depth. So I kind of estimated how much the depth was, about 15 centimeters, and then I calculated how far left and how far right it was. And so I got a volume. And then I went to the site. When you go to the site and you buy bark, they don't say, do you want 1 bark or 2 bark? They actually measure it in terms of cubic meters or cubic volume. So you can buy them as cubic meters. You can't buy them as cubic kilometers because it's too big. But cubic meters, if you had to picture it, how big? It's 1 cubic meter. Anyone picture that right now? Yeah, it's about a meter. Meter's about 1 step length. So you try to picture 1 step across, 1 step across, and then 1 step up. That's roughly a box. All right, so that is how much you get in terms of bucks. So the question is, how much of that do I need? And when you look at a box, it kind of doesn't look like a lot. But when I worked it out, I actually only needed 2. And what's interesting is that it came and it looks huge. Oh, this massive truck came and everything came about and it fell on the front lawn. I had to shovel it up into a wheelbarrow and wheelbarrow it all the way back to the back and pour it in. But what was interesting was that it was exactly what I had predicted. I would get, because it wasn't exactly 2 cubic meters, it had about 1.8, so I had about a bit left over. So where would that leftover go? I just thought, I'll check it over this side, and it was true. It was roughly about that amount. So it told me that, hey, those volumes and those cubic conversions were so useful to me. But then recently, which was, when was that? It was the start of this year, I used another conversion that was useful. Before I teach you that one, this is the conversion of capacity, which is liquid. Okay, so when you go buy things that are solids like that, they're usually measured in cubic meters, cubic centimeters, often cubic meters for anything to do with landscaping. This one, you probably work more with milliliters and liters because that's often where we're at. We don't ever touch big M. Big M is for megaliters, and then this is kiloliters. Okay. Now, the conversion rate, notice it's different to the volume. It stays as 1,000 for each one. But there is one useful conversion, and I'm curious to know how many of you know this. Anyone know how to convert from volume to capacity? What is that, Raph?
Isn't like 1 centimeter cubed 1 milliliter or something?
Beautiful. Write that down if you did not know. One cubic centimeter, and if you had to picture, where in your time have you seen 1 cubic centimeter? Anyone know? Yes. Those little unit blocks that you got back in primary school that you count as units. That's 1 cubic centimeter, which implies if you were to pour 1 mil into a measurement and then you could pour into the cubes, that's how much those cubes would hold. Okay? Now, if this is true, then let's use what we currently know. We know that 1 liter is how many meals again? How many meals in 1 liter? 1,000. So we know that there is 1,000 meals in 1 liter. So that means how many cubic centimeters would there be? Okay. Now here's my other question. Does anyone know how to convert cubic centimeters to weight? Or can we convert volume to weight? Anyone know the conversion? Well, that's how they do it. But anyone know the actual conversion? Just out of curiosity.
Doesn't it vary with the density of what you're measuring?
Yes, it does. But in general, you can use it as a estimate, and it's approximate. But that's exactly right. You have to then take account of the density. You didn't know? 1 mil is equivalent to about 1 gram. So, if I wanted... So that means, on a rough estimate, 1 liter, which is 1,000 mils, should be equivalent to, roughly? Roughly? What's the weight? So 1 liter is 1,000 mils, and each mil is about 1 gram. So then how many grams should you have?
1 kilogram.
All right, beautiful. So 1 liter is approximately 1 kilogram, roughly. Now, why am I sort of telling you that? Is because bleach bath. So my daughter, she has really intense eczema, and she scratches herself. Recently, she uses because it's hard to cut the nails for infants, she has some sharp edges. And when it gets really itchy at night, especially when you're sleeping, you don't know when she digs it in. And she actually digs it in. She actually stabs her face with her thumb, and then she does this twist, right? She does this twist, and then by the time I see it and I grab her hand, she pulls it off, and she rips her skin, and it bleeds, and then she does that over and over, so the scabs never really heal. So this morning, she just did it again. And I put clubs all over it. But anyways, beforehand, one of the ways that we can try to manage the itch is that you gotta reduce the amount of eczema. If you don't reduce it, it flares up and it gets really itchy. And at the time, we had no idea. We actually went into severe categories. So it was like really flaring up, and I just thought it would just go away over time. Then we had a virtual doctor over the phone, and we were recommended bleach bath, and they said go to the RCH and have a look at the conversion rate. So bleach bath means that you put in bleach, literally, but there is a concentration that they want you to have. So the concentration is about 0.05%. That's the ratio of water to bleach, okay? And for those who did not know, which the general public, 12 mils for every 10 litres is much easier for the general public to understand. But I understood that, so that's what they recommended on the video call. And so my wife went onto the website, did a bit of research, and we found that this right here, that information there, so I took that, and here's the problem. Not a problem per se, but imagine as parents for the first time, we're trying to fill up the bathtub. And remember, here's a bathtub. We got one of those ones that kind of looks like this, has a inbuilt sort of seat, and it sits just on a stool. Right? You can pull off that seat.
Wait, I've never seen one that has a standing one.
Yeah, so it's a standing one, so you don't have to bend over or squat. My wife wanted to be able to stand to keep her lower back. Just for the kid.
Oh, yeah.
So water goes in there. Water goes in here. Okay? Now, now let's do a bit of calculations here. 12 mils for every 10 litres. So 12 mils of bleach for every 10 litres of water. Right? So this is water. So it's a 12 to 10. Okay? If we worked out the percentage, what's that percentage? How would you work that out? Because at the moment they're saying final bleach concentration of 0.05%. How do you work out the percentage? How would you do it?
You find 12 as a percentage of 10 litres.
Yeah, you'd find 12 as a percentage of 10 litres. Now, because this is in mils, that 10 litres is not in the same unit. So what's 10 litres as mils? 10,000. So this 12 to 10 doesn't make sense because it's not 12 mils to 10 mils. It's actually 12 mils to 10,000. But we can work this out. 12 to 10,000. Is that an extra zero? Oh, sorry, it is too. 12 to 10,000. Did I do an extra zero? No. 12 to 10,000. If you just did a bit of quick calculations, what's the decimal there? Is it? You're just dividing by the number of zeros, but you can already see. I'm using a calculator for you to see. Actually, I'll do a calculator here. Here we go. Calculator. 12 divided by 1, 2, 3, 4. Makes sense, right? Because you're dividing by that 10,000. 1, 2, 3, 4. Now. Fair call? But yes, that's right. Now, if you multiply this, yes. So this is what I'm asking. When you're thinking about this, how do you work out the concentration percentage in terms of how much of a percent do you need? Now, if you multiply this by 100, huh?
I get it.
Well, what are you doing?
So, final bleach con. You want this? Yeah. the final bleach concentration, right? Meaning the total amount of bleach that you could put in there is you can only put 50 liters in there. I mean, of water. Do you get it? Because if you put too much bleach while with the water, oh no, you can wait. Sorry, it's 40 liters. Because then there'll be more than 0.005 concentration of bleach in the. Do you get it?
Very good. So the point is that the point is that this is the maximum that you can get, right? You just don't want to be passing over that. And I guess when it comes to then pouring in here, the amount of water that this can contain, we're saying it's 12 mils per 10 liters. It doesn't mean that this can hold 10 liters. So how much can this actually hold was the other problem I had. And then whatever you put in there, you then have to adjust the amount of mils of bleach you put in. So if each tub is different, so how do you measure this at the moment when I measure it with my daughter? I know that for her to comfortably sit in here, the water reaches about just her armpit. The nice thing is I have a weight scale on it. There's a weight scale that you can actually press.
Fancy bathtub.
Yeah, I know.
How much was this bathtub?
I think it was about $40 for that one.
What?
That's expensive. Yeah, I know. It's huge. That's expensive.
That's so cheap.
How's that cheap?
$40.
Yeah. All right, let me pause the video for me. I'm glad I didn't record that bit. All right. Volume is equal to, now they say it's area times what again? Height. But really, volume, which we know is about 3 dimensions. So area is the space that it covers in 2 dimensions. So this is the 2 dimensions, right? The height, why is it called the height? It's just to help you visualize what's actually happening, but it's not necessarily the height. It's actually the 3rd dimension. That's how you get your volume. So you could have an area a cylinder that's on a side, but you wouldn't call that the height. You would actually just say, this is the area, which the proper name is called a cross-sectional area. That's right. So that's why when they say height, when I first teach it to year 8s, usually they keep looking for the vertical height because of the language. We say height. So I try to teach you that you need to understand it's the 3rd dimension that makes it a prism. Because like what Sunny said last time, if you got an area and you expand it or you extend it in the 3rd dimension, that's how you get a 3D shape. So when they say times height, what they're actually saying is multiply by that length that creates it into a 3D shape. Okay, thanks boys. That's the only thing I wanted to highlight. That's why this topic is on volumes of prisms and cylinders, because cylinders and prisms share that same property. In terms of working out the volume, we can see it's pretty much the same as usual. Cross-sectional area is the 2D area that we can see there. That's why they say area ends up being x times x, or back in primary school, length times width times height, because length times width gives you the cross-sectional area, times height is the 3rd dimension that makes it a prism. Okay, and that's why the volume of a cylinder is similar as well, because the cross-sectional area is currently a circle, and we know that the area of a circle is?
Pi r squared.
So that's why it's pi r squared times, and even though it's h, it's actually the 3rd dimension that makes it a prism. Okay? So that's the last exercise. I just thought it was a nice conversion units, because I've had kids in the past where they say, when will I ever use this? And it's not about that. It's about the problem solving, the thinking, how to make your life a bit easier. Most people will get through life without thinking. We'll get through it just by doing. But if there's efficiency, then why not use a bit of logic, right? You have to know what to ask them. Yeah.
No, just ask, like, do this, and then I'll do it.
Take a photo of yourself.
You can try. You can try. I'm not going to argue. You can use whatever it is